Hello everyone, welcome to Kumbha Science Academy. Today we will see our last chapter, differentiation, whose exercise we were about to perform. But before going to exercise number 1.2 of the differential equation, I would like to introduce you few important concepts. What are those concepts? So, most important thing, we are finding the inverse of a function within this exercise 1.2. We will find the inverse of a function, and most importantly, how to find the inverse of a function first, and then we will find this derivative. Before going to find the derivative of the given particular function, okay, of that inverse function, I would like to introduce you this inverse process. Okay, so inverse process is fundamentally dealing with what? Okay, so this inverse word is most important. Okay, so what is the important factor of this inverse? So whenever we finding the inverse of any kind of function, that function deals with one important parameter. So what is the inverse of 3? Inverse of 3 will be, so if I am considering in number, in terms of number, so 3 is into inverse of 3 will be what? 1. Okay, so all we know that this common sense. Okay, so 3 into 1 upon 3 is equal to 1. Okay, that's how we are finding the inverse. Now most importantly here, what we are performing this binary operation, and which gives us a 1. Now similarly, in terms of a function, we have this relation with this one particular y and relation between x. So if I now substitute, so this is the simple binary operation where we are finding the inverse. So as you can see over here, okay, so this 1 upon 3 is inverse of what? 3. Okay, so this example is done. Up to this point we know. Okay, so this is the simple method. Now what is the inverse of particular function? Okay, so if I am considering the function y is equal to f of x. Okay, y is equal to f of x. Again, now to find out the inverse in terms of x. Now inverse of y in terms of x, what it could be? So in terms of x, if we are finding the inverse, then most importantly it should be like this. So this f of x, I am continuing, so we need to perform the reverse operation. Okay, this reverse operation is known as the inverse function of this y. Okay, so you will get this x again. So common sense says that, so f inverse f of x. So again this will give you the important parameter x. So this f inverse acting on this particular function will give you that x. Is common sense says something like this. Okay, I am not talking in terms of mathematical terms. I am talking in terms of what? In simple manner, how we can find out the inverse. Okay, in terms of mathematics, this function, if you consider in terms of mathematics, y is equal to f of x have its inverse. Okay, the inverse when the function should be have relation. Okay, so the function should have the particular relation. So which kind of relation we are talking over here? That relation, okay, that relation should be 1 on 2. Okay, otherwise we can, in simple words, what we can say, the function have, or what we can say, function should be 1 1 and on 2. Okay, so this is the most important parameter which we are putting whenever we are finding the inverse of given function. Now these parameters which we have already introduced in our 11th standard. Okay, so we know this parameter. So most importantly, that function should be 1 1 and on 2. On that basis only we can find its inverse of this f of x. F of x inverse we need to find out on this basis. So this point is clear, done. It should have some interval. So that particular interval, okay, so that interval is most important part, but we are not dealing within this derivatives concept, okay, or do we? Yes, we are dealing with this interval concept, okay. Most importantly, another one factor we need to have, okay, in terms of differentiation. So whenever we are finding the derivative, of the particular function, then again this should be differentiable with respect to x. So this y or function should be differentiable. I am writing it very precisely. If you look at it properly, then this is the proper parameter. These two parameters are there, and most importantly, dy upon dx should not equals to 0. Then only we have this differentiation process regarding these inverse functions. Now they have given all these parameters, but we are not focusing on those parameters. What we are focusing about this inverse function is whenever we are finding, okay, dx upon dy, okay, so it should be again 1 upon dy upon dx. Okay, so this is most important factor which we need to resolve within this topic. Now next step is what? Next step is says something like this: dy upon dx should not be equals to 0. And again I am writing different equation. Okay, what is that? Dy upon dx, most probably we are finding this only. We are not dealing with this. So right now I am doing this. Okay, so you are also doing this. So that's why this condition is quite important. So dx upon dy, look at it properly, dx upon dy, again this dx upon dy should not equals to 0. Now this is the shortcut, okay, towards this topic. This topic is too wide. Now why we are dealing with this inverse and how we are using this inverse, that's a different thing. First of all, we need to understand what are the fundamentals of this inverse. Okay, so whenever we are finding the function or we have particular function, at that time what we are looking towards is functions variables. Okay, so we are first of all looking towards the functions variable. So within this f of x, okay, y is equal to f of x. What is the variable? Most important variable is x. Okay, so this x is most important variable, and that x should have some relation with this y. Now this y and x are interrelated, then only possible things are coming in front of us. Now here, hope so I am clear with this f of x and x. Okay, so f of x says that it should have some relation with y, and how that relation is 1 1 and on 2. Next step is what? It should be differentiable within particular intervals. Now next step is what? Dy upon dx should not be equal to 0. Then only we have this dx upon dy is equal to 1 upon dy upon dx. So this is most important parameter we are putting in this case. Now why we are doing this? Anyhow we know dy upon dx, so we need to just make its inverse. So 1 upon that particular dy upon dx is equal to particular value. Accepted. But in few cases we have this important parameter. How? Because if you look at it properly, okay, so I would like to move to directly trigonometric functions. So I am not taking in detail of those trigonometric functions, but I would like to give some essence. What is that essence part? So when we are dealing with this log of x is equal to, otherwise what we can write, y is equal to log of x. So what should be inverse of x? What should be inverse of x? Removing log on both sides. So what should be inverse of y? Okay, so in terms of x, so removing log on both sides, what you will get? Making it exponential. So removing log means what? Is simply nothing but y into log of e is equal to log of x. Okay, so this is we know. This how we can proceed. Now next step is what? Log of e raised to y is equal to log of x. Now next step we can remove the log on both sides. Therefore e raised to y is equal to x. So common sense says that x is equal to e raised to y. Now most important thing, this is the inverse in terms of x. I am giving you a simple one example. Okay, so that's how we can find in terms of operational inverse. Listen it carefully what I am saying. Operational inverse of this function. Now most of the students are thinking like if you want to find out the inverse, so common sense says that, as we introduced you earlier, that y into inverse of y is equal to 1. Okay, so that's how they are dealing with these functions, but this is not true. So if you are finding the inverse, so here what it says, this equation says something like that: y raised to minus 1 is inverse of y. Okay, so this equation says something like that. Okay, but it doesn't mean that 1 upon, so y is nothing, y raised to minus 1 is nothing but 1 upon y. Okay, so again next step, what is y? So most of the students are doing this stupidity, that log of x. So inverse is something dealing this process. No, this is totally wrong. This is possible in terms of binary operation. So operational, which kind of operation, which kind of operator you are operating on that function is deciding which kind of inverse you are getting. Okay, so that's how this is exponential inverse of that function y. Okay, this is not true. Okay, in terms of numbers it is true, but in terms of function this is true. Understood? So most importantly, what we need to do, we need to understand how exactly this inverse is we are obtaining. Okay, so I hope you understood through this example how exactly this is not inverse of y in terms of x. Okay, but this is the inverse of y in terms of x. So if you look at these two properties, now how sir this is possible? Yes, it is possible. Look at these two properties. Okay, so x, if you substitute x within this bracket, what you will get? You will get again y. How? Yes, so y is equal to log of, substitute this x within this log, what you will get? E raised to y. Again this is nothing but y into log of what? E, which is equal to y. So this log of e is what? 1. So this gives you y. So y is not losing its identity. What? Y is not losing its identity. Y remains as it is. Okay, so we are not changing y. What we are doing, we are just finding its reverse process, how we can get that y out of that equation. Hope you understood how exactly we are dealing with this parameter. Most of the students are not getting these factors just because they don't know how exactly they are performing these factors. Now important factor is what? If you again substitute this value over there, you will get the identity. Accepted, no issue. But main problem is what? You need to look at this equation properly. Okay, so this, if you substitute these values within this equation, correct, but most important what? So y, inverse of y, if you substitute over here, you will get 1. Again if you substitute, again you will get that value, but you won't be able to differentiate it. Understood? You won't be able to differentiate it with respect to this inverse. So this is the only process where we can have this inverse differentiation. Okay, so that's why we need to find the inverse in this manner, not in this manner. Okay, please focus on this topic. Okay, once you understood this, then only you can go through the next big problem. So just look at it once. You know all these parameters. There is one theorem which is quite important in terms of 12th standard of HSC board. Now let's move how we can deal with this parameter. So I would like to extend again this factor also. So I will do here. So I will do it here. Those who have confusion regarding the operation and function, okay, so operation of particular pattern, okay, gives us particular relation, and that relation and that function deals with that total variables. So most important, you need to understand which kind of operation you are operating on which kind of function. So there are a number of operations which can be possible. So this, if I substitute this value over here, so y is equal to, so y into 1 upon log of x, which is equal to 1. So y is equal to log of x, which is true. Accepted? Accepted. Now most importantly, if I want to find out the differentiation in terms of x, now what we can do? So in terms of x, how we can differentiate this parameter? Okay, so if I differentiate, then just see what will happen. So y is equal to our equation. Let me remind you that equation earlier we wrote. So x dx upon dy, okay, it should be what? 1 upon dy upon dx. Okay, so this is what we need to find out first. So first thing is what? Dy upon dx. What is dy upon dx? Substitute the values 1 upon x. Hope we are correct. Okay, any doubt? No doubt. Now next step is what? Dy upon dx. Now if you look at it properly, okay, they are saying that this function should be differentiable. Okay, this function should be differentiable. If I differentiate this, so what I am getting? Dy inverse upon dx. Okay, so I need to find out this differentiation. So I would like to find out the differentiation. So d inverse upon dx is equal to d upon dx of log of, no, not log of, 1 upon log of x. Okay, so if you differentiate this function, what you will get? So 1 upon something something, that minus sign will come outside. Okay, so what will happen to this? So d upon dx of log of x, minus sign comes outside, because this minus raised to this factor will give you this minus sign outside. So this whole parameter have this important factor. Okay, so I would like to keep it as it is. So minus 1. So log of x raised to minus 1. Again, if you differentiate by chain rule, what you will get? D upon dx of y inverse. Okay, be focused on this thing. Why I am performing this, I will clear it, but wait for a second. So once we differentiate with respect to chain rule, what will happen? So minus 1 comes over here into log of x raised to minus 2 into 1 upon x. Now you can see how complicated this scenario is. Okay, so this gives me one hint: minus 1 upon x into log of x bracket square. Hope you are getting this thing. Now if I say this x, okay, so here if I said something like this for this equation, okay, this is the inverse of this function. Okay, then if I multiply this equation into this equation, can we get our required value? No. So it should be again 1. So dy upon dx into d inverse upon dx is not equals to 1. It is not equals to 1, and that's how we have this problem. Hope you understood. If you just multiply it, so this is what 1 upon dy upon dx. Okay, so we are multiplying it. So 1 upon x, okay, 1 upon x into minus 1 upon x into log of x square bracket square actually is not equals to 1. Anyone can see it. Anyone can see it. And that's how we don't have this inverse. We are not using this kind of inverse. Hope I have made my point clear that how this y raised to minus 1 is not functional inverse of this given y. Okay, understood? So this is not the inverse. So this method, or what we can say, this equation is not satisfied by this inverse format. Okay, this is most important concept, this is most important step which students need to understand, but people are not thinking about it. They are just following what they have to do or whatever they have to do, or then performing this task, but they are not understanding what they are exactly doing. They are not thinking about it properly, and that's how they are wrong in terms of entrance exams. Now this is the quite important parameter. Now you can see over here this equation deals with most important parameter, how this, again I am repeating it again and again, how this y raised to minus 1 is not functional or operational inverse of this y. So what is our y? Y is equal to log of x. So it should not have this inverse. What it should have? It should have this inverse, this as an inverse. Now let me introduce you again that how this equation is correct. So I will perform. So 1 upon x is I performed. Now I want to find out the inverse. Okay. So I will do one thing particularly. So dx upon dy. So what is our x? Our x is e raised to y. Substitute. So x is e raised to y. So d upon dx of e raised to y. First, what is the derivative of it? So e raised to y. So most importantly, this is y. So what is the derivative? So derivative will be e raised to y only. Okay. So e raised to y. So e raised to y is nothing but again x. Okay. E raised to y is nothing but x. If I substitute within this parameter, so my parameters are saying something like this. What are my parameters? So if I substitute within this equation, so this dx upon dy into this multiplies to here. So dy upon dx should be equals to 1. And how it is possible? By doing this step. So dx upon dy. So substitute the values dx upon dy. What is the value of dx upon dy? Is nothing but x. Okay, into what is the value of dy upon dx? Is 1 upon x, which is true, and that's how we can prove this theorem. So therefore initially what we were looking for, so dy upon dx into dx what first was not equals to 1, but using our this step. Okay, so using our x as inverse or operational inverse of y, we can prove that this is equal to 1 and this is not equals to 1. Please try to understand how exactly I am doing this thing and how important this is. This is so much important task in terms of what? Inverse operation, or what we can say finding the inverse operational and its derivative. So therefore, so far I am clear. So first of all, whenever we are finding the inverse of the given parameters, what is important? The important task is what? We need to find out its proper operational inverse. We are not finding its binary inverse. Okay, what we are finding is operational inverse, and that operational inverse is the only key factor to find out the derivative. Okay, so then only we can say that the given inverse function has particular derivative which can be again inverse of that particular function. Okay, so in shortcut what we can say, differential inverse. Okay, so differential inverse parameter we need to find out. Hope this is quite fuzzy to you and quite confusing, because you never thought about this kind of things, why this is not possible and how this is possible. Hope I'm clear up to this. Thank you. So we saw exactly how we can deal with this inverse process. So within this inverse process, we have to tackle with another one important parameter, that is called as inverse trigonometry. Now inverse trigonometry is quite haunting for the students, because most of the time they are preparing inverse trigonometry so much and suddenly they know they don't know anything. So kind of chaos thing they are appearing through this inverse trigonometry process. Now we will discuss some standard equations of this inverse trigonometric function and how exactly we can differentiate them using this inverse differentiation process. Now most importantly, you need to understand this first, then only we can proceed further. Otherwise it's just a waste of time and lots of confusion in mind. So hope you got it. Now let's move to further application of this inverse differentiation. Now what is the further application of inverse differentiation, sir? So that is what we are about to see, that is inverse trigonometric functions, how exactly or how we can tentatively apply this process to the inverse functions. Okay. Now inverse function, first of all we need to understand what is this trigonometric function. Okay, so trigonometric function quite having this behavior of, most of the students are thinking that this inverse, finding the inverse of the trigonometric functions is the same as they are thinking about the other functions, but it's not the reality. Reality is something different. Now if you look at the function, okay, so trigonometric inverse functions when we are finding, so sine of x is equal to some particular value of what? The sine of x, instead of sine of x we were using theta, is equal to what? Y upon r, and cos theta is equal to x upon r. Okay, this was very well known process for us. Okay, so I am erasing this inverse. Okay, this is the trigonometric functions. Now this is what? Trigonometric function. Okay, hope we are getting this. Now this is what trigonometric functions. So trigonometric functions here we are dealing is very simple. So when we are finding its derivative, okay, so we all have these values with us, but what is about this theta and what's about this r? Okay, so when we are dealing this with r is equal to unit radius, okay, so we will have this in our parameter. This is theta, this is r is equal to 1, and this is x, this is y. Then our cos theta is equal to what? So sin theta is equal to y and cos theta is equal to some x. Okay, most important. Now if you look at this properly, this x and this theta, this x and this y are independently changing. Okay, this x and y are independently changing. Okay, they are not dependent on any other parameter. They are not depending on each other directly. They are depending on each other by with respect to this theta. Okay, so this is called as something implicit function. Okay, so implicit function, explicit function. So we need to discuss about that also. So that's the most important parameter. So they are indirectly connected to each other. Therefore, what we need to do, we need to differentiate this and this with respect to theta. So dy upon d theta is equal to something called as, so if I differentiate this whole quantity, so what you will get? You will get something like this cos theta. Okay, and dx upon d theta is equal to what? Minus sin theta. Okay, that is for sure. Everybody knows that. Now what is the most important thing? So dy upon d theta, which is nothing but what? X. Very very interesting. And d what? dx upon d theta, which is nothing but minus y. Understood? So that's how it is very interesting to understand in this parameter. So why this derivative are related to each other? How they are related to each other? Okay, so we can see how they are related to each other. The derivative of this function with respect to theta, if you took, so dy upon dx d theta is equal to x and dx upon d theta is equal to y, then anyone can easily tell what is x and what is y. Okay, we have this seen over here. But in terms of inverse process, so this inverse process is totally different. So what we are doing over here within this inverse of this trigonometric function, okay, so I am not deriving all those tan theta, cot theta and all those parameters, okay, all those ratios. I am doing only with, I am dealing here only with this theta and sin theta and cos theta. So if I want to do it in terms of inverse, okay, inverse metric function, okay, so scene is quite different. How, sir? Look at here, sin theta is equal to y. I am taking it, okay. So what should be our theta? Theta is equal to inverse process of y, inverse process on y. So how it is inverse of sine? So we need to understand what is this inverse. It doesn't mean that this is equal to 1 upon sine upon y. This is not equal to this. Okay, the most important thing is what? This process is inversed. Okay, this process of sine, taking sine, is reversed or inversed. Okay, within this case, therefore we are getting sine inverse of y. Okay, so this is not equal to this. If I want to write this equation again, so sine inverse of sine theta is equal to sine inverse of y. Okay, hope you got it. So this sine will be cancelled and only remains what? Theta, which is equal to sine inverse of y. Most important thing, and that's how we are dealing with this theta. Okay, hope you got it. Now next step is what? Again another parameter. If cos theta is equal to what? X. Again cos inverse of theta, sorry, cos inverse of cos theta. Okay, so cos inverse of cos theta will be equal to something like this. Okay, so something like this is equal to cos inverse of x. Again, very important thing, very important parameter. What is that? The most important parameter will arise like this: theta is equal to cos inverse of x. Now this theta equals to cos inverse of x. It comes over here. Theta equal to sin inverse of y. Then what exactly this relation? This relation is what? Cos inverse of x is equal to sin inverse of y. Look at it properly. Okay, so very interesting parameter we are finding over here, that this cos x, cos inverse of x should be equal to sin inverse of y. Now how many of you have looked at this equation like this? Okay, I don't know whether you are looking these equations in this pattern. Okay, look at it properly. How interesting is this equation? This equation is quite interesting. If you look at this equation, cos inverse of x is equal to sin inverse of y, then how it is possible, sir? Because the theta is same. So all those parameters are dealing in this inverse process is what? Only this theta. So once we are having this theta, what is the value of this theta? On that basis only we can find the value of x and y. On that basis only we can find its derivative and how exactly that function is changing or varying, or what we can say, having these variations, we can find out. Okay, so integration parameter comes up to this. The next important thing should be like this: what if you take the derivative of this? Okay, if you want to differentiate these two parameters, okay, so if it's like this is this dy upon d theta is equal to x, okay, that's we got, and dx upon d theta is equal to this, that is also correct. Okay, no problem. Now in terms of inverse, if you look at this equation, okay, so we should have some different parameters with us. So I'm not dealing with that right now. What I would like to do, I would like to focus on this parameter only. I will deal with this parameter in exercise number 1.4. Okay, so keep in mind, now here for this kind of equation, how it is possible to find the differentiation. Now if these two quantities are same, then their derivative should be same. Listen it carefully. If these two quantities are same, then their derivative should be equal. Will it be possible to find their derivative? And if their derivative is found, then their derivative should be equal. Okay, that's simply indicating, this equation simply indicates what? If you differentiate it, so differentiating on both sides, what you will get? D upon D what? What we need to do? We need to find out the value of x, and then only we can differentiate it. So d upon dx of cos inverse of x should be equal to d upon dy sin inverse of y. But we cannot do it. We need to differentiate with respect to x on both sides. Understood how this equation is complicated? I bet you, what I am saying, I bet you, if you solve this equation, you will find the magic. Now, that's how this equation is quite interesting. So, d upon dx of cos inverse, I am writing it again and again, okay, to make focus on this important equation. So, dy. Otherwise, if you differentiate with respect to x also, okay, no issue. Okay, because we are operating on both sides similarly. So this should be equal. Yes, this should be equal. These two equations should be equal. Can you see the magic? Okay, so we are dealing with this dx. Now if I differentiate this equation with respect to y, then also it is true. So dy upon cos inverse of x, it should be equal to d upon dy of sin inverse of y. It should be equal to. It should be equal to. Now I am focusing on that important parameter. Now what is the meaning of this equation? What is the meaning of these equations? Now look at it properly. Okay, so when we are solving this kind of equations, at that time we will have one particular chaos. Okay, so what is that chaos? Chaos means what? We have certain type of limitations, and on those limitations we need to focus. Now what are those limitations? The cos and sin are never be equal at particular instance. How they are equal? At 45, most of the students are giving these answers at the same time, that cos theta and sin theta are equal at one particular point when it is equal to 45. Okay, both are having different values at different angles. Okay, so they never be equal. Understood? Then how could be their inverses are equal at particular point, at particular theta? Understood? And that's how we deal with this problem. Okay, if you look at this problem carefully, okay, so we will have these important values. These values are something different. Again and again I am emphasizing, just try to solve this equation. Okay, so whether this is true, false or whatever it is, okay, just try to solve it once. Okay, now let's move to further part of the differentiation of this equation. Now we will find the inverse differential equation of this equation. So inverse, when you are finding the okay, so inverse trigonometric function and then differentiation. So most importantly, sin theta, I was writing it like this y. Okay, now if I took it, theta is equal to what? Sin inverse of y. Okay, sin inverse of y. Now here y is variable. Okay, but which kind of variable we are dealing? We are dealing with the independent variable. The y is independent, y becomes independent over here, and this independent variable most probably written in terms of x. Hope I am correct. So most of the time we are writing this as a x. Okay, so this y. So I will replace it sine inverse of x. Now this is again variable. Most importantly, now this x, we are substituting some x and having particular function f of x. Obviously this is particular f of x. Now this f of x again we can compare with y. So I am replacing this theta with respect to y. Nothing else. Nothing else. Okay. So what is this y? This y has its own dimension, that is called as our dimension. Instead of dimension I would like to say y has the particular value of unit angle. So angle, this is what? Angle. Okay, and this is what? Our variable. Okay, now most important thing, that's what we need to focus within this whole course. Now we will differentiate this y with respect to x. We will differentiate this y with respect to x, where our x is having particular interval. So what is the interval of x? So x interval can be written, most of the books they are written, okay, it is lesser than, greater than, something. So what should be greater than or lesser than? So it should have the closed interval, x belongs to this closed interval. Okay, so this closed interval says something like this, -1 to 1. Okay, I am correct. Okay, so we are not proceeding or preceding more than this one, or we are not having the less value than this -1, but it can be equal to or greater than. So in our textbook it is written like this, -1 is less than or equal to x, less than or equal to 1. Okay, so we are dealing with this, and this is also having the same meaning, nothing else. Okay, so let's follow the book. So we have this -1 less than or equal to x, less than or equal to 1. Now what is our next case of y? So y should be, or y either greater than or lesser than something. So it should be having value of what? -pi/2 to +pi/2. So what is -pi/2? So -pi/2 less than or equal to y, less than or equal to pi/2. So in terms of theta we are having this value. Now most importantly, what we need to prove, we need to find its derivative. Now how to find the derivative of this function? What is the procedure? How to find the derivative of this kind of function? So we have particular value of this equation. Yes, of course we have. Now what we can do? We need to deal with it. Now how we can deal with it? Okay, so first we need to find out the derivative. Oops, got it. Now here differentiating the equation, instead of differentiating we need to correct this equation. So y is equal to sine inverse of x, therefore x is equal to sine of y. So again most important step, again we are going to this step. Okay, so we got it. Now next step, differentiating both sides with respect to y. Differentiating both sides with respect to y, what will happen? Dx upon dy is equal to d upon dx of what? Sorry, d upon dy of sine of y, which is equal to cos of y. Is there any doubt? No. Now as simple as that. Now next step, what we need to do? We need to go to the value of cos of y. Now what is the value of cos of y? Cos of y having particular value. So what should be that? So dx upon dy is equal to what? Is equal to plus minus under root of cos square y. Am I correct? Yes, of course. We need to proceed further on this basis. Now next step. Now what is the value of cos square y? So most of the students are thinking like this, we need to substitute the value of y directly. No, wait for a second. What is the value of this cos? It having the value of plus minus under root of 1 minus what? Sine square y. Now substitute the value of y within this case. So plus minus under root of 1 minus sine square of What is the value of y? Sine inverse of x. So most important step. Most of the students are asking me this question rapidly. So if sine square of x is equal to sine x bracket square, then why it's not possible to consider this sine of x raised to minus 1? Most of the students asking me this question. Okay, so most important step, do not forget, this is one of the operation. This is what? One of the operation, and we have the proof of this operation. Okay, we have the proof of this operation, and the proof of this operation says that this is not equal, and this operation is equal. So whenever we are applying sine 2 times on x, listen carefully what I am saying. Whenever we are applying sine 2 times on x, that should be equal to sine x bracket square. Understood? Okay. But whenever we are having the inverse function on this x, it should not be equal to reciprocal of sine of x. Okay. So hope you got it. This is most important step. So similarly over here, people get confused and ask me. Okay, most of the engineers ask me this kind of question. So one of my engineering student asked me, how sir this is not possible? I have learned this process, I have mugged it, and I went through the exams, I cracked this AT and all the stuff. Now I am becoming engineer, but I still have confusion regarding this step. Now why this is not equals to and how this is equals to. So this is the kind of explanation, and that's why I thought to discuss with you. Okay, so please don't forget that this is the inverse process. This inverse process does not equals to the reciprocal of sine of x. Now next step, we need to move further. So plus minus under root of, again substitute the value. So 1 minus sine inverse of x bracket square. Look at it properly. Next step, plus minus under root of, what should be its value? So 1 minus, this is x square. Okay, hope you got it. Now next step is what? Now dy, so dx upon dy is equal to this. Okay, so instead of here I would have to write dx upon dy is equal to this. Then what should be dy upon dx? So dy upon dx is equal to, should be 1 upon dx upon dy. Substitute the value, you will find the value definitely. Now we cannot take the under root. So what we need to do? We need to leave it like that only. Now what is the most important parameter within this case? So 1 upon under root of 1 minus x square. Now sorry, what's about the plus minus sign? Okay, so plus minus sign gives an hint. What is that hint? They have said to us in the question that x, mod of x should be what? Greater than 1 or lesser than 1? Mod of x should be what? Mod of x should be less than 1. So due to this situation, mod of x should be less than 1. Due to this condition, this value remains as it is. It's not greater than 1. So common sense, this value will not get negative value. Again, our problem is over here only. So if we squared it and do it, and particularly we are getting those values, so there might be chances of plus minus. Okay, so that plus minus depends on what? The value of x. So if x is not greater than, the mod of x is not greater than 1, then common sense says something like this: this should be, this whole bracket should be positive, and it should be positive, and therefore we are getting the positive value. Therefore dy upon dx equals to what? 1 upon under root of 1 minus x square at mod of x less than 1. Now most important thing. So what happens if this mod of x is not less than 1? If mod of x is not less than 1, what will happen? Nothing will happen. It is always this case. Okay, this is the particular case and we have the value over here. Okay, we have the value over here. It should not proceed, okay, or it should not exceed 1. It should not exceed 1. If it exceeds 1, this situation is invalid. So we cannot apply this situation. Most important thing. And therefore this value contains this parameter. Now this can be applicable to the inverse function of tan, cos, cot, tan, cot, sec, cosec. At that time we required this mod in different parameter. Okay, so right now this is permanent situation. Now next step, this problem was quite easy. This wasn't the problem, this is the only case which we are learning. This whole system is what sometimes called as composite function. So this composite function we differentiated directly but using one trick of this inverse process of this function. Now what is the value of cos, what is the value of tan, what is the value of inverse of sec. So inverse values, okay, so we will differentiate it and afterwards we will have their values. So I don't like to perform those stuff over here. I would like to directly write those values. Okay, every proof is given in the book, but we will proceed that it will give us particular value. So just note it down first and then we will move to our next important stage, which is called as our exercise number 1.2. Now we will see the formulas regarding this inverse trigonometric functions differentiation. Okay, so let's focus on the formulas, okay, instead of derivation of those formulas. So in book they have given us plenty of different formulas. Now how to choose out of which are usable, okay, and how to use them. So we will focus on those formulas directly. So how to derive we saw. Now we need to focus on one particular parameter, okay, then we will see how to substitute them. But while solving the problem I would like to introduce you how to how to do the substitution process. Okay, so I am not taking right now that methodology, so I would like to directly perform or take the close look of those formulas. Okay, so what is our first formula? So inverse trigonometric function differentiation. Okay, so that's how we will perform. So first formula is what? D upon dx of sine inverse of x is equal to how much? Is 1 upon under root of 1 minus x square, where this most important boundaries condition are so minus 1 less than or equal to x, okay, and less than or equal to 1 where y is minus pi by 2 less than or equal to y less than or equal to pi by 2. So this is the most important parameter. So within this parameter we need to fit our equations. Okay, now next part is what? Next formula is cos inverse of x. So here again the cos inverse of x, how it is valid and why it is valid, so we will see that. So d upon dx of cos inverse of x is equal to minus 1 upon under root of 1 minus x square. Okay, so minus sign difference is only there, so everything is same. Again, this is most important condition that mod of x should be less than 1. Now what, sir, if these are not valid cases? So if it mod of x is not less than 1, how it is, means what should be this value? No, most of the time it is equal to, or sorry, less than 1, but therefore we are directly using this formula. Okay, there is no other case. If there is other case, we need to think about it differently, but in our syllabus we are not studying the different case rather than this. Now let's focus to our next step. So our x value should be again, okay, so how we are deciding x value? So minus 1 less than or equal to x less than or equal to 1. Okay, so this is how we are considering this value, because we know that cos inverse of x is equal to y. So commonly cos of y is equal to x, and we know for any angle theta, this value does not proceed great, means it should not be greater than or lesser than, okay, that particular value of -1. It should not be less than -1 and it should not be greater than 1. Similarly over here also it should not be greater than 1. So sorry, it should not be greater than 1 and should not be lesser than -1. So therefore we are using this condition on this basis. Okay. So next step is what? Again y, how are we choosing this y? So 0, angle 0 less than or equal to y, less than or equal to pi. Okay, so we know that where the maximum value arises. So this is the general solution for this. Okay, so this is the principal solution what we are looking towards. So within this 360, what we are looking, this is what? 0, angle theta is equal to 0 over here, or 2 pi or 2n pi. Okay, so we have this kind of values. Okay, but we are in principal solution, therefore we require only 0, and here the maximum value is what? Pi. Okay, so within this boundary our pi is working and our value of -1 and 1 is valid. Okay, therefore we are taking this 0 to pi. Same case with this minus pi by 2 also. Okay, so let's see how it is possible. Now next step, next formula is tan. So d upon dx of tan inverse of x is equal to, what should be? So 1 upon what? 1 plus x square. So that's simple. So 1 plus x square, and again what should be the value of x? X should have some particular region. Okay, so it should be belong to one particular value, that is called as real value. So that x belongs to the set of real numbers. Okay, it can be anything because it is a ratio. It is a ratio of sine upon cos. So therefore it has particular limitations, or what we can say variations within that function. So therefore this x belongs to R. And again what should be this boundary of y? So y boundary says that y which is in greater, y is greater than or equal to minus pi by 2 and less than or equal to pi by 2. Okay, then only our function is valid. Okay, most importantly, then only our function is valid. So these are the cases or the situations are chosen on basis on what? Our sine theta. Okay, so that's what we are getting within this case. Now next step is what? Cot. So d upon dx of cot inverse of x. Very interesting term we will get. What is your guess? Again it is minus sign. So minus 1 upon 1 plus x square. Again this x belongs to real value, real numbers, and again the next step is what? Our value depends on what? Cos. So how to remember? So this 0 less than or equal to y and y is less than or equal to pi. Here we are dealing with tan inverse of x is equal to y. Okay, so for this case, how to remember this situation is what? So I am explaining you. So tan of y is equal to x. Okay, again sin y upon cos y is equal to x. Okay, so what is the situation where we are having trouble? So that situation is what? Cos, this sin. So for sin purpose we are using this. Similarly in terms of cot y is equal to x, so cos of y upon sin of y is equal to x. Again what is the condition for cos? Cos condition is what? 0 less than or equal to y and less than or equal to pi. So we are applying that situation. So these two cases are different. Okay, so please remember this step, how exactly we are performing this. Now next step is, next formula is again important one, the cosec inverse of x and sine inverse of x. We done. All these formulas are regards one particular value of x. Okay, so as x value varies or mod of x varies, we are having this variation. And again in terms of sec, okay, sec and cosec, we have different considerations. So hope you got it. These formulas are given in book, okay, so that's not a big deal. What is the big deal? We need to remember, memorize them and apply them properly, then only it is possible. And these cases are most important. Okay, for HSC board they are not giving extra any cases, okay, for HSC board, but for CBSE board they have particular values, okay, on the basis of their inverse intervals. So there are different intervals where this inverse function can vary, and they are using those values, okay, and they are specifically putting this kind of question in CBSE board. So don't worry about those questions because that's not a part of our syllabus right now. Okay, so let's move to our sec and cosec terms. So sec inverse of x, again having interesting value. Okay, so we need to look at that. So sec is nothing but what? So if I put sec inverse of x, okay, so what should be our situation over here? So 1 upon x into under root of x square minus 1. So x into under root of x square minus 1. Okay, okay. Now again, what is the next same? So here we have the value for particular value of x. Okay, so what is the particular value of x? For x is greater than 1. This is the case. Now what is the next case? Minus 1 upon x under root x square minus 1. For what? You have that common sense. So it should be again having this, if x is less than minus 1, then only it is possible to put that minus 1 over here. Okay, so most importantly, okay, so for last 2-3 years, okay, they didn't give this kind of information regarding this sec inverse, but they have introduced with this interval of minus 1 and 1. So don't forget it. This is most important and crucial formula. Whenever they have given you the x is less than minus 1, then you need to use this value. Okay sir, how we are getting this minus 1 and plus 1 values? So it depends on the coordinates. Okay, so they will definitely give, and in problems I will explain you. Now most important task is done. Now another most important part is what? That interval part. So if interval part dealing with these values, so what should be another condition? Y should not be equal to pi by 2. How? Because, okay, so I will explain this step. Why y should not be equals to pi. So sec inverse of x is equal to y. Okay, so sec inverse of x is equal to y. Now what should be sec y? Sec y is equal to x. Now what is this sec y? 1 upon cos y is equal to x. Now if y equal to pi by 2, then it will be 1 upon 0, which should not be our case. So this is not defined situation or undeterminate form. Okay, so non-determinate form or undeterminate form, whatever you want to say. Okay, so which is not valid in mathematical case. Therefore y should not equals to pi by 2. So hope what is the reason behind it you understood. Okay, now let's move to next step. All the other values are valid, okay, within that interval from 0 to pi. Okay, so within that 0 to pi we can apply any value for this. Okay, don't worry about that another case. So this is very crucial step we done. Now hope you got it. Just note it down in your short notes. Okay, so this is kind of tough situation where we need to understand what is the meaning of this equation also. So hope you got it. Now let's move to our cosec inverse of x. So d upon dx of cosec inverse of x. What is that value of cosec inverse of x? So cosec inverse of x, again having very interesting parameter. What is that? Again here is the change. Okay, this value will flip. How exactly that cos and cosec's value were shifted? Similarly we need to, sine and cosine values were shifted. Okay, so similarly we also here shift in this sec and cosec values. How? So minus 1 upon x under root of x square minus 1. Okay, so it is quite opposite. Now what should be the condition of that x? X again, for x is greater than 1. Just check it out whether it is correct or wrong. Correct. Now next step, again I will take this value for 1 upon x under root x square minus 1 for what? For x is less than minus 1. Very interesting. It is simple to understand and it is simple to memorize it. But what you need to understand, this is dealing with cos and this is dealing with sine. As I told you initially over here. So similarly this is cosec inverse of x is equal to y, and again cosec y is equal to x. So 1 upon sine y is equal to x, and for this situation y should not equals to pi or 2 pi or n pi. Okay, so most importantly y should not be equals to pi. Okay, so then only our case is valid. So therefore our most important step rises like this: y should not equals to pi, then only this formula can be applicable. Now here what we need to do, we need to just again put the f of x instead of x, and we will have our composite function. So as you can see, this is only one particular function. Now if you want to differentiate the composite function, so for that composite function what we need to do, we need to just put that f of x by f of x instead of x, and again all the values are similar. Hope you got it. Now let's move to the problem session. Okay, so they have given another few charts and their derivatives. Okay, so just look at those particular values and just apply them, and f dash of x, don't forget to find out the f dash of x. And very interesting one thing, they have given all the inverse function formulae. Okay, so how to use them, how to apply them. Okay, hope you have brought or made that chart of the inverse trigonometric functions and the trigonometric functions. Just prepare the trigonometric functions, definitely it will help you, and inverse trigonometric function we will about to see, and afterwards we will see the substitution. But right now I am not taking the substitution, I am directly going to the problems. Okay, so let's start with the problems. Okay, exercise 1.2, question number first. Now question number first says that first find the derivative of the function. Find the derivative of the function y is equal to f of x using the derivative of the inverse function x is equal to f inverse of y in the following. So we need to look at this question properly first. So this question is about, so y is equal to under root of x. So first question says that y is equal to under root of x. What we need to do, we need to find out first inverse of y in terms of x. Okay, so we will simply write it like this. So we will find, we first find inverse of y in terms of x. Okay, so what does that means? So y, if y is equal to f of x, then what should be inverse? F inverse of y is equal to x. You already know this factor particularly. Now we are again emphasizing and again on this particular parameter. Now what is the meaning? So now what we need to do, we need to square, okay, on both sides. Therefore y square is equal to how much? Y square is equal to one particular value, that is what? X. So x we got. Now next step is what? So this is what? X. So x is equal to y square. Now squaring done. Now differentiate both sides with respect to y. So differentiating both sides with respect to y. Now is there any difficulty? No. So dx upon dy is equal to d upon dy of y square, which is equal to 2y. Okay, hope so we are clear up to this point. Now next step is what? We need to put this equation as 1, this equation as 2, and this equation as 3. We already know what is the value of dy upon dx. dy upon dx or dx upon dy is related to one particular factor. So that particular factor we know. Again, we need to move to further one part. What is that? We need to say something like this. So differentiating with respect to x, we go differentiating with respect to x is different thing. So differentiating equation 1 with respect to x is what? Dy upon dx, which is equal to d upon dx of what? Under root of x. Now most important parameter is what? 1 upon dx upon dy. We already have this. So we need to what? We need to just substitute the value. So substituting the value, what you will get? So substitute this 2y. So 1 upon 2y using equation 3. As you can see, using equation 3, we have just substituted the value of dx upon dy, which we have already. Now next step is what? Dy upon dx is equal to 1 upon 2y, which is again equals to, what is the value of y? So y's value is under root of x. So 1 upon 2 under root of x, which is true. So we already have this value in initial differentiation. So using dx upon dy, we can find the value of dy upon dx, and that's how this inverse differentiation process works. Understood? So therefore this problem was quite easy. So it's actually easy, but again we are differentiating in terms of or using the inverse process. Okay, now let's move to further question, which is quite interesting and again important one. So within this next question, so y is equal to something is given. Okay, so just wait a second. Okay, y is equal to under root of, okay, so something is given. Our next question is related to what? Y is equal to under root of, question number 2 of question number first, y equals to under root of 2 minus under root of x. Now again here we first find inverse of y is equal to this function under root of 2 minus under root of x. Now next step is what? Squaring both sides. So y square is equal to 2 minus under root of x. Now next step, under root of x is equal to 2 minus y square. Okay, should not be any difficulty over here. Again squaring both sides, you will get x is equal to 2 minus y square bracket square. Now this is equation number 1. Now next step, this is equation number 2. Differentiating both sides with respect to x, what you will get? Dx upon dy is equal to, what is the value of this differentiation? So it is nothing but what? D upon dx of 2 minus what? x square bracket square. So all you know, okay, so if you differentiate with respect to x for this value, so it is quite similar to that also. So we need to just put that y over here, okay, that's it. So this is the f of x square, so it will be 2 into whatever our f of x, so 2 minus y square remains as it is, so 2 minus 1 will be 1, and again differentiation of what, 2 minus y square, so which is quite easy. So 2 into, again what is this value, 2 minus y square into, what is the differentiation of this will be 0, this will be minus 2y, okay, so multiplication will give you what, minus 4 into 2 minus y square into y. Hope so I am clear up to this step. Yes, I would like to substitute these values. Why I am doing it separately? Okay, so just focus on this parameter. So if I want to do it directly, so I could have done it directly, but I am showing you how I am tending to this answer. Okay, so look at it properly. So this will help you. Why? I will give the reason for that. So d upon dx, what is the value of x, is 2 minus y square bracket square, so which is equal to what, minus 4 into 2 minus y square into y. Now cool and calm. So we have differentiating both sides of equation 1 with respect to x. Otherwise you can say differentiating y with respect to x. So differentiating y with respect to x is what, dy upon dx, which is equal to 1 upon dx upon dy, okay, by theorem. So by inverse theorem we come to this conclusion. Now next step is what, I am keeping this, okay, I am keeping this equation alive, okay, so you can understand what is the meaning of this, because this will help us. Now dy upon dx is equal to what, 1 upon dx upon dy. So this is equation number 3, okay, I am good. So this is equation number 3. So substituting the value of equation number 3, what we will get? So here you will get minus 4y into 2 minus y square, okay, okay. Now next step is quite complicated. What you need to do, you need to substitute the value of this y within this bracket, so then only we can solve this equation. So let me give some reason to it using equation 3. Now next step is what, so we solved this equation and found the value correctly. So our this value is also correct. Look at it properly. Okay, everything is good. Now let's move to further part of substitution. Now what we are substituting the value of y. So it is quite like most of us thinking that if we can solve it directly, why we are doing this process? Just to remember that this can be done. For that purpose we are solving this problem. Okay, so if you can eat like this, so why you are eating like this? So that can be the question of you in your mind. So next step, I am substituting the value. So I would like to take minus and upper side. So 4 into under root of 2 minus under root of x into 2 minus, what is the y square, is nothing but 2 minus under root x. Okay, hope I am correct. Yes, I am correct. Now substituting again those values, okay, directly I am writing y square because you know y square value is over here. We can substitute it or we can put it. Now next step, minus 1 divided by downward, so 4 into under root of 2 minus under root of x into, this bracket will get open and this minus sign will get cancelled, so this will be under root of x only. And check out the answer. Our answer is correct or wrong? Our answer is correct. So therefore we found the answer, which is quite certain, and here we are. So therefore this is the dy upon dx. Okay, good. So this is the dy upon dx of this given function by using inverse process. So what's wrong with our common process which we learned earlier? Okay, so nothing is wrong. Okay, we are just trying these things in different manner. That's the difference. Nothing else. Now what is our next question? होप तुम्हाला समजत असेल या सगळ्या गोष्टी. मी मुद्दाम म्हणून इंग्लिशमध्ये शिकवतोय कारण की तो तुमचा फ्लो थांबला नाही पाहिजे. ओके, सो डोंट वरी अबाउट इट. ओके, सो आय विल कम इन मराठी ऑल्सो वेन एव्हर इट इज रिक्वायर्ड. ओके, होप सो अप टू दिस टाइप ऑफ प्रॉब्लेम इज इझी. सो नेक्स्ट स्टेप, पुढचा प्रॉब्लेम कुठला आपल्याला त्याच्याकडे वळायचे. y इज इक्वल टू व्हॉट? y इज इक्वल टू क्यूब रूट ऑफ x मायनस 2. Now here is something interesting, as I given you earlier that chart. Okay, so I will erase all these things. Okay, so let's erase it anyway. Okay, I know that my English is not that good, but still I am trying to teach you in English. Why? Because most of the students are saying that people are also having the problem with English. Okay, still मराठीत बोलायला काही प्रॉब्लेम नाही, पण सायन्स एक अशी गोष्ट आहे जी आपण इंग्लिश मधून शिकतोय. दॅट विल बी कम्फर्टेबल फॉर यू ऑल्सो अँड मी ऑल्सो. सो नेक्स्ट स्टेप, आय एम फीलिंग क्वाइट गिल्टी रिगार्डिंग दिस मराठी थिंग. ओके, सो मला मराठीत बोलायचे, मी मराठीमध्ये घेणार आहे लेक्चर, पण ही तर सगळ्यात महत्त्वाची गोष्ट समजून घ्या. ओके, की आपल्याला ज्या वेळेस आपण सायन्स शिकतोय तर सायन्स शिकत असताना इंग्लिशमधून शिकणं फार गरजेचं आहे सध्या तरी. ओके, बाकी सगळे पॅरामीटर्स तुम्ही इंग्लिशमध्ये वापरताय, त्यामुळे इंग्लिशमधून शिकणं थोडंसं गरजेचं आहे आणि त्यामुळे मी मग इंग्लिशमधून बोलतोय. ओके, याच्यातून तुमचंही प्रॉफिट आहे, माझंही प्रॉफिट आहे. बाकीचे राहिलेल्या सगळ्या इमोशनल गोष्टी आपण बाजूला ठेवून जस्ट फोकस केलं पाहिजे कशावरती, तर आपल्या स्टडीवरती. तरी पण मी प्रयत्न करतो. y इज इक्वल टू, ओके, कुठलं घनमुळे का, हे कुठलं मुळे? घनमुळे. मराठीमध्ये आपण काय म्हणतो? घनमूळ. ओके, तर आपण हे कुठलं मूळ काढतोय? घनमूळ. तर घनमूळ दिलेलं आपल्याला किती? x वजा 2. सो y इज इक्वल टू दिस. सो देयरफॉर डिफरन्शिएटिंग बोथ साइड. सो डिफरन्शिएटिंग, नॉट डिफरन्शिएटिंग डायरेक्टली. ओके, so we can do it, but still we need to find its inverse. So we first find inverse of what? Y is equal to cube root of x minus 2. घनमुळात x वजा 2. बरोबर. मग आता आपण काय करणार पुढे याचं? सो दोन्ही बाजूंचा घन करू, म्हणून काय होईल? 3 क्यूब. सो y क्यूब अंडर रूट जो काय आहे तो क्यूब रूट जो आहे तो निघून जाईल. सो देयरफॉर x minus 2. So that will be remaining part. Now next step is what? X is equal to y cube minus 2 का plus 2. That's it, nothing else. बस इथपर्यंत आलो आपण. Now differentiating both sides with respect to x. Okay, with respect to x? No, with respect to y. मगाशी मी with respect to x लिहिलं होतं चुकून. Now with respect to y, आपण जर का दोन्ही साइड डिफरन्शिएट केलं तर काय भेटेल आपल्याला? सो dx upon dy is equal to d upon dy of y cube plus 2, which is quite easy. फक्त त्याचा आन्सर सिंपल आहे. एकदम किती येईल? y 3y square plus 2 नाही 0. okay, so plus 0, so nothing remains. So that's the simple value. Now again we have dy upon dx 1 upon dx upon dy. तर एक छेद dx भागिले dy. मग आता आपल्याला उत्तर किती भेटलं पाहिजे? तर आपल्याकडे ह्याची व्हॅल्यू आहे का? आहे. आपण आता ते सगळे नंबर्स वगैरे देत बसत नाही, आपण डायरेक्टली व्हॅल्यू सबस्टिट्यूट करू आणि पुढे सरकूया. मग पुढे काय येईल व्हॅल्यू बघा. दिस 1 अपॉन व्हॉट? 3y स्क्वेअर. ओके, So all of you know that we have the value of y over here. Now we can substitute that value. Okay. So substitute it. So 3 into what is the value of y? Y value is nothing but cube root of x minus 2. Okay, and again it's bracket square because this is the y square. Okay, so I am not confusing you. So this is the simple step. Now again next part is quite interesting. पुढचा पार्ट बघा कसा इंटरेस्टिंग आहे. काय होणार आहे पुढं की आपल्याला ह्याचं पॉवर शोधून काढायचं. त्याची पॉवर किती आहे, ह्याची पॉवर किती निघते तुमच्या मते? सो इट्स पॉवर इज नथिंग बट 1/3. सो x minus 2 bracket raised to 1/3 raised to 2. So therefore dy upon dx is equal to 1 upon 3 into x minus 2 raised to 1/3. ओके, हे फक्त ह्या पार्टचं झालं. आता वरती परत पॉवर किती आहे? 2. मल्टिप्लाय करा, प्रॉपरली आन्सर भेटेल तुम्हाला. सो 1 upon 3 into x minus 2 bracket raised to how much? 2/3. Very very sweet. Okay, so very very proper one. So hope तुम्ही इथपर्यंत आलात. आता आपल्याला काय करायचे ते ही व्हॅल्यू आपल्याला भेटली आणि दॅट्स आवर फायनल आन्सर. होप सो वी आर करेक्ट. येस वी आर करेक्ट. आणि त्यांनी दुसऱ्या पण पद्धतीने दिलेलं आहे याचं उत्तर. सो हे उत्तर पण बरोबर आहे आणि त्यांनी दिलेलं पण उत्तर बरोबर आहे. त्यांनी फक्त काय केलंय, हा जो भाग आहे 2 तो आतमध्ये घेतलाय. मग आता 1/3 तसं पण कॉमनच राहतो. ओके, सो मुलं जिथं कन्फ्यूज होतात ते हे सगळ्या सिंपल स्टेप्स आहेत. ते ह्या स्टेप्स मध्ये मुलं कन्फ्यूज असतात. स्क्वेअर अगेन रेज टू 1/3. तो 1/3 चं तुम्हाला मीनिंग माहितीच आहे. मग त्याचं उत्तर किती येईल? सो 3 क्यूब रूट ऑफ x minus 2 ब्रॅकेट स्क्वेअर. ओके, तर ही 8th स्टँडर्डची स्टेप मी तुम्हाला करून दाखवते. की कुठल्या स्टँडर्डची? 8th स्टँडर्ड म्हणजे 8वीच्या पुस्तकात तुम्ही बघितलं तर हे आहे. ओके, सो एकदम सिंपल अशी स्टेप होती, आपण परफॉर्म केली. ह्या बारक्यासारख्याच गोष्टी असतात जे मुलांना कन्फ्यूज करत असतात. ओके, सो याच्यामध्ये काही घाबरून जाण्यासारखं नाहीये. नॉट इवन हिअर ऑल्सो. ओके, सो दिस अँड दिस बोथ आर सेम. नाउ नेक्स्ट स्टेप इज व्हॉट? आपण पुढच्या प्रॉब्लेम कडे वळूया इन्स्टेड ऑफ वेस्टिंग टाइम. पुढचा प्रॉब्लेम काय सांगतो आपल्याला? सो y is equal to log of 2x minus 1. Look at this problem properly. ओके, या प्रॉब्लेम कडे पूर्णपणे लक्ष द्या. आता हा प्रॉब्लेम काय आहे, इथं बाकीच्या सारखं आपल्याला काय स्क्वेअर वगैरे 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 तसं काही करायचं नाही. याला फंडामेंटल्स आपल्याकडे पाहिजे. मग काय आहेत फंडामेंटल्स या प्रॉब्लेमच्या? तो क्वेश्चन नंबर 2 नव्हता, क्वेश्चन नंबर 3 होता. ओके, जो आपण केला. मी थोडंसं विसरतो नंबर टाकायला. ओके, ट्राय टू अंडरस्टँड, प्लीज ऍडजस्ट मी. क्वेश्चन नंबर 4th. तो क्वेश्चन नंबर 4 says that y is equal to log of what? Log of 2 minus 2x minus 1. Most important. Again we need to find the inverse of this function. How? So we first find inverse of y. So what is the inverse of y in terms of x? ते शोधायचे आपल्याला. So therefore y is equal to log of 2x minus 1. We know that. Now next step y into log of e, जे भरपूर पोरांना माहिती नसतं, into log of 2x minus 1. आता तुम्ही log of e घ्या, आता तुम्ही बेस टू 10 घ्या. ओके, सो बेस टू 10 घेता तर थोडंसं गोष्टी कॉम्प्लिकेटेड होतात. ओके, सो मोस्ट प्रॉब्लेम मी प्रेफर करेन log of e घ्यायला. आता log of e का घ्यायचं सर? ओके, सो त्याच्या मागे पण एक खूप मोठी स्टोरी आहे. सो log of e आणि log of 10 यांचं रिलेशन आहे 2.203. ओके, 2.203. यस, 2.203 ही व्हॅल्यू आहे. त्याने मल्टिप्लाय करावं लागतं log of 10 ला. त्यानंतर मग तुम्ही कन्वर्ट करू शकता त्याला log of e मध्ये. ओके, सो ह्या सगळ्या ज्या बेसिक कन्सेप्ट त्याच्यामध्ये आता न पडता आपण फक्त एकच डोक्यात ठेवायचं की log of e is equal to 1. सो इथं y into 1. ओके, ते कुठल्याही नंबरच्या मल्टिप्लिकेशन मध्ये 1 असतो. मग that 1 can be log of e. So I'm taking that log of e. Understood? इथं काय मॅजिक नाहीये. ओके, it's not a magic. Okay, it's a simple mathematics. So we are substituting this with log of e. And again this y raised to some value of e raised to y. Okay, very very interesting. Log of 2x minus 1. look at it properly how I am converting this. Now removing log on both sides, you need to put that word, or we can directly remove that log. So e raised to y is equal to 2x minus 1. Okay, removing log on both sides. We focus on this particular point. Removing log on both sides, we can have e raised to y into 2x minus 1. Now next step is what? So this 2x is equal to e raised to y plus 1 and x is equal to e raised to y plus 1 divided by 2. Very interesting equation we got. Now you can see how much trouble we are having up to this point, okay, to convert it into inverse. Okay, so this is not that easy as we were thinking. आपण जसं विचार करत होतो की खूप सोपं जाईल, सोपं नाही येत एवढं. नाव मी आता डायरेक्टली त्याला डिफरन्शिएट करू शकतो. ओके, आणि डिफरन्शिएट करून परत dy upon dx मध्ये कन्वर्ट करत. सो डिफरन्शिएटिंग बोथ साइड विथ रिस्पेक्ट टू y, what you will get? So look at this equation properly. So differentiating both sides of this equation number 1. Okay, so no, not 1. This should be 2. So this should be 1. So differentiating both sides with respect to y of equation 2. Okay, got it. Now next step, now once we differentiated it, now next step काय असणार आपल्याकडे? dx upon dy is equal to what, sir? So this should be differentiated directly. So if you can, it's okay. Otherwise do it step by step like this. So d upon dy of e raised to y plus 1 divided by 2. So you will get e raised to y upon 2. That's it, nothing else. So and 1 upon 2's derivative will be 0. So e raised to y remains as it is. So e raised to y divided by 2. That's the differentiation of this equation. Now next step is what? We have dy upon dx is equal to 1 upon dx upon dy. So therefore substitute the values. So 1 upon e raised to y divided by 2, which is equal to 2 upon e raised to y. Okay, बघा नीट बघा इक्वेशन. भरपूर जण माझे व्हिडिओ बघत नाही आहेत सध्या, वाईट वाटते फक्त एकच गोष्टीबद्दल की एकदम इक्वेशन महत्त्वाचं आहे. आता बघा इक्वेशन मध्ये करंटनी कशी येते. सो हाऊ एक्झॅक्टली वी आर चेंजिंग द व्हॅल्यूज. सो 2 upon what? Most important, 2 upon e raised to value of this log of 2x minus 1. ओके, आता तुम्ही मागे जाऊन उत्तर चेक करता त्यावेळेस खूप तुम्ही फ्रस्ट्रेट होता. ओके, तो व्हॅल्यू ज्या वेळेस तुम्ही चेक कराल क्वेश्चन नंबर 4 च्या, तर त्यावेळेस तुम्हाला खूप टेन्शन येईल की सर हे कसे काय आले व्हॅल्यूज म्हणून. ओके, आता हितपर्यंत तर सगळ्यांनी आले असेल. ओके, आणि जी सगळ्यात महत्त्वाची आयडेंटिटी आहे ते मुलं वापरायला विसरतात. ती कुठली वाली आयडेंटिटी मी ज्या पद्धतीने सांगितली आहे, आयडेंटिटी कुठली वापरणार मी? e raised to log of f of x is equal to f of x. This is the most important formula which I am emphasizing from last 2-3 lectures. Now we will use this formula over here and answer will be 1 upon 2x minus 1. And that's the final answer of our question number 4. Now again without pause we need to move further. So what is our next question? Our next question, so hope तुम्हाला कळला असेल हा क्वेश्चन किती महत्त्वाचा आहे आणि याच्यामध्ये फक्त व्हॅल्यू सबस्टिट्यूट करायचे. सो वी हॅव, आता आपण इथं असं रिझनिंग दिलं पाहिजे का पुस्तकात आन्सर देत असताना? सो ज्यावेळेस तुम्ही आन्सर लिहिता त्यावेळेस तुम्ही अशी रिझनिंग करा, तिथं व्हॅल्यूज लिहा. ओके, तिथं कुठलं बॅड इम्प्रेशन येणार नाही तुमचं पुस्तक. तुम्ही जर का अशा आन्सर्स लिहिली, यू राईट दिस काइंड ऑफ आन्सर इन युअर एक्झाम, सो it's not the bad thing. Okay, that will create some good impression on the examiner. Okay, and obviously these questions will be asked for this 12th standard board only. Okay, this kind of question will never come in CET board, CET exams. Okay, so whenever you are writing, write it properly with your particular reason. So this was the question number 4th. Now let's move to question number 5th. Now what is our question number 5th? The question number 5th is again quite easy. Now look at that question number 5th. Y is equal to 2x plus 3. Now I am not doing this problem. Okay, so I am leaving this problem for you. So I would like to do the question number, which one? Sixth one. So question number sixth. So question number 6 says something that y is equal to e raised to x minus, hope so 3. Yes, correct. So 3. Okay, so again we need to find the inverse. So we first find inverse of y. Okay, now how to find the inverse? So y is equal to e raised to x minus 3. Okay, done. Now taking log on both sides. So instead of taking log directly, I would like to suggest you one thing, that take this 3 at this side. So y plus 3 is equal to e raised to x. So x can be lonely over here. So taking log on both sides. Okay, both sides. So this will be very easier. So taking log on both sides. So log of y plus 3 is equal to log of e raised to x. What should be the answer? So again, simplifying this equation, you will get x is equal to log of y plus 3. That's it. Nothing else. That's it. Now differentiating both sides with respect to x, you will generate particular value. Okay. So differentiating, this is equation number 2. This is equation number 1. So differentiating both sides with respect to y. So differentiating both sides with respect to y. What you will get? So dx upon dy, which is equal to d upon dy of log of y plus 3. Okay, good. Now next step. So we are having our answer over here only. So this is most important step is here. Okay, so whenever you will find how to take this x out of that function and convert it in terms of x, sorry, in terms of y. Okay, that's what we are doing here. Now next step is what? So dx upon dy is equal to what? So log of f of x is equal to 1 upon f of x. So y plus 3 into, what is the derivative of f of x? Will be 1. So this will remains as it is. So इथपर्यंत कळलं कारण की ह्या परत y plus 3 चा डेरिव्हेटिव्ह किती यायला पाहिजे? y plus 3 चा डेरिव्हेटिव्ह येतो परत किती? 1च. Okay, so nothing else we are getting out of that. So again value substitute. Okay, so I would like to substitute afterward, but I am doing it over here only. So y, what is the value of y? E raised to x minus 3 plus 3. So this will get cancelled and this will remain as 1 upon e raised to x. Now again take the value. Okay, so dy, okay, so we know, or we have dy upon dx is equal to 1 upon dx upon dy, which is equal to 1 upon e raised to x, which is equal to e raised to x only. So at a first sight, if anyone knows, at a first sight, if you differentiate this equation with respect to x, you will get only e raised to x, and everyone knows that. And still using the inverse process, if you differentiate it, still you are getting the value of e raised to x. Hope you understood this simple problem. Now let's move to the question number 7th. So question number 7 is again simple. It is similar to this question only. So I am not giving any kind of hint. So I would like to go for question number 8. Okay. So we will solve the question number 8 out of this question. So question number 8 says that y is equal to log of 2. Log of, not log of 2, log of x by 2 base to 2. Okay, so we will solve that question. So y is equal to question number 8. I am doing the question number 8 because 7th is similar to the initial problem. The question number 8 is something like this. y is equal to log of x by 2 base to 2. Now there is nothing to worry about this base to 2, but most of the students have this confusion with them. So therefore I would like to solve this problem differently. So we first find what? We need to first find what? Inverse of y in terms of x. Okay, so inverse of y. What is the inverse of y over here? As a function we will find it. So y is equal to log of x by 2 base to 2. Okay, log of x by 2 base to 2. Now next step, any guess what should be our next step? After this step, is everything good? So y is equal to log of 2 base to 2. Okay, next step is what? Log of 2 base to 2. Why I am doing this? Log of 2 base to 2, because it is 1. Okay, its value is 1. Therefore log of x by 2 base to 2. Okay, everyone knows that log of a base to a is equal to 1. Okay, everyone knows that. Now next step is what? Substituting the values. What we will get? So this is nothing but 2 raised to y. So here again log of 2, okay, raised to y base to 2 is equal to log of x by 2 base to 2. Any problem? No problem. It's okay. The next step is what? Very interesting. Removing log on both sides. What you will get? 2 raised to y is equal to x by 2. So 2 multiplies over here. So x is equal to what? 2 into 2 raised to y, which is equal to 2 raised to y plus 1. Most important equation you are getting. Now what is that equation? X is equal to 2 raised to y plus 1. Now differentiating this equation number 2, what you will get? So differentiating equation number 2. So differentiating equation 2. So this is equation 1. This is equation 1. What you will get? With respect to what? Y. What you will get? So dx upon dy is equal to d upon dy of 2 raised to y plus 1. Okay, no problem, no issue, nothing else. So this is quite easy. Okay, so differentiating using which law? Or no, chain rule. So which rule? Chain rule. So you will get 2 raised to y plus 1 as it is into log of 2. Okay, done, no problem. Now next step, into what is the derivative of this? This is nothing but 1. So f of x is nothing but y plus 1 and this derivative will be 1. So this equation remains as it is. Okay, no change. Now this is the simple one, done. Now substituting the value, what you will get? What is the value of y? Value of y is log of something 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 something. So again 2 raised to log of y. Okay, so log of y plus 1 na? So I would like to take that 2 outside. So 2 into 2 raised to y into log of 2. Okay, no issue. So if I take this 2 to the power of 2, then again we should not have any issue. So 2 raised to y log of 4. Why? Because it's a 2 square. And what is the 2 square? Is nothing but 4. So I am writing it directly. Okay, so hope this step is done. Now substitute the value of y. So 2 raised to log of x by 2 base to 2 into log of 4. Again we are having that formula. What is that formula? A raised to log of f of x base to a is equal to f of x. Okay, so apply that formula over here. What you will get? So this is nothing but our x by 2 into log of 2 raised to 2. So I would like to keep this 2 raised to 2 as it is. Okay, so we will have this magic over here. So therefore this power is again goes to multiplication over there. So log of 2 raised to what? 2 into x by 2. So x by 2 into 2. So this 2 will get cancelled and remains as what? Only x. That's it. That's the value after substitution, and all we know is okay. So up to this step done. Now what we need to do? We need to just make its inverse or find its inverse. Otherwise you can write this equation as x log of 2. X log of 2. Why? Because that 1 by 2 goes to here and this power will get vanished, and therefore you will get the value as we have written. Now this is the most important step. Substituting these values we have, so this is what dx upon dy, and we have what we have, dy upon dx is equal to 1 upon dx upon dy. Look at this equation carefully. Now substitute the values. So 1 upon x into log of 2. Just check our answer whether it is correct or wrong. Okay, so yes, it is correct. Okay, so that's how we are getting up to this conclusion, and we are having the value of dy upon dx is equal to 1 upon x into log of 2. Now as we were starting this problem from this point, and as I emphasized earlier, these two equations, okay, so these two equations were quite easy, but still people are finding some difficulties in solving these equations. So a into a raised to log of f of x base to a should have this f of x, and in terms of e raised to log of f of x is equal to f of x. So both equations are having very strong impression, and therefore we are using them over here. So as I told you earlier, these two equations are quite important. So we will stop over here. So in next video I will perform the question number 2, 3 and so on, because the introduction part and this question number 1 of exercise 1.2 is covered within this session. So this takes some time, okay, and please I am saying please try to watch whole video, because it contains so much different aspects and different knowledge. Okay, it's not that different, but to improve your understanding I am giving each and every step. Okay, so please watch whole video. Okay, instead of watching the starting and end part and downloading it, is not sufficient for you. Okay, and it's not sufficient for the 12th standard also, because there might be chances of starting our school after this, within this 15 June. Okay, due to the corona we are not doing our 12th standard properly, I know that, but still this examination section is at our head ahead. Please watch the whole video and try to solve the question on your own. मला माहिती आहे सगळं हे जड जाते. थोडक्यात सांगायचं म्हटलं तर एकच गोष्ट आहे की स्वतःहून सोडवल्याशिवाय पर्याय नाही. मॅथमॅटिक्स जर का तुम्ही म्हणत असाल की तुम्हाला सहजासहजी समजून येईल, तेवढं सहजासहजी ते समजून येणार नाही. मी फिजिक्स नाही शिकवते पहिल्यांदा, मी केमिस्ट्री नाही शिकवते, मी डायरेक्टली मॅथमॅटिक्सला स्टार्ट करतोय आणि त्याच्यात हा अवघड चॅप्टर मी स्टार्ट केलाय. सो हा अवघड चॅप्टर का म्हणतोय मी, कारण की मुलं नंतर जंबल होतात एक्झाम्सच्या टाइममध्ये आणि त्यांना असं वाटतं की त्यांना सगळं काही येतं. ओके, आणि ते जंबल अशा प्रकारे होतात की त्यांना काही सुचत नाही. सो इट रिक्वायर्ड सो मच प्रॅक्टिस. म्हणून मी म्हणते परत तुम्ही या टॉपिककडे ध्यान द्या आणि खूप महत्त्वाचे व्हिडिओज आहेत. ओके, सो वी विल स्टॉप ओव्हर हियर आणि पुढच्या सेशनमध्ये मी पुढचं पार्ट कंटिन्यू करेन. ओके, थँक्यू.